back. In this lesson, we're going to talk about constructors. Now, initializing all the variables in a class each time an instance is created is actually tedious. Even when you have some convenient functions like the set dim that we have added. So it is actually simpler and more concise to have all of the setup done at the time the object is first created. So Java is actually allowing us to is allowing objects to initialize themselves when they are created through the use of a constructor. So what is a constructor? A constructor initializes an object. Immediately you actually create, immediately an object is created, the constructor initializes it. Now, normally the constructor has the same name as the class in which the constructor resides, and also it has syntax that is similar to a method. The syntax of a constructor is similar to a method, the name is similar to the class. So the defined constructor is automatically called after the object is created before the new operator completes. Now, constructors don't have return types. Now, the reason as to why they don't have return type is because whatever they are returning is the implicit return type of a class. So the constructor's job is to make sure, or is to initialize the internal state of an object so that the code that is creating an instance will have a fully initialized and even usable object immediately. So I want us to work on the box example so that we can have the dimensions of the box being automatically initialized when an object is constructed. So to do that, we need to go and replace the set dimension method. We replace it with a constructor. So we have this set dim. I want us to replace this method, this one, with a constructor. Okay. So remember we said that the constructors one, let me literally delete everything. We say that the constructors, they do not have return types. Remember we said that. And they have the same name as the class. So the name is box. And they follow the same syntax as a method. So that means we need to have parameters after them. Then we have curly braces. Now, inside this constructor, we are going to initialize our width. So let's say width is equal to 10. We say height is also let's give it 10 also. Let's assume it's a cube, and then depth, let's give it 10 as well. So we are actually initializing. We don't have depth, we have length. Sorry, this be length. We are using this constructor. Let me put a comment here and say constructor so that you don't get lost. So using this constructor to initialize values for our instance, or the classes that will be created rather. Okay, then from there we can still have I want us to shift this method here, this method that we use to compute the volume. Let's shift it to come below our constructor. It will come below our constructor. So here we are computing. We need to compute and return the value. So we are no longer displaying. Let me remove this comment here so that it doesn't mislead you. So we are computing and returning volume. We are computing and returning volume. Of course, we said we need to have what the method returns. The method is turning double. The method name is volume, and then we have the return statement in there, where it's returning the results of the product of the length, the width, and the height. So we're done with our class. Let's move to our main now. So inside our main, we are going to declare, we allocate, and we even initialize the box object. So here, this we're going to leave this one. Box my box 1 is equal to new box, then box my box 2 is equal to new box. These two statements are actually declaring my box 1, my box 2. They are locating them and they are initializing them. So then we have double vol, going to leave it that way. So what we're going to do here is, let me remove this. After we have done all these declarations, down here we are going to let's get the volume of the first box. Volume of first box. Notice that initialization of the dimensions, we have done that in the constructor. So to get the volume of the first box, we just need to assign vol, and we call volume on my box 1. So my box 1 dot volume, and that's it, guys. Yeah, so the moment we do that, can do the same for the second box, is equal to my box 2 dot volume, my box 2 dot volume, and we put that my box 2 dot volume, and we put that. Now notice we are just calling this and assigning in here, but we are not printing all this, so we will need to print. Let's print the volume so that we can see the results. So system dot out dot print ln, we are printing vol, so we are printing vol at this level. So let's also copy this so that you can print vol for my box 2. Alright, so we can now run this. Let's check the results. See 1000, 1000. The reason is because we have just set same dimensions in our constructor here. All these have the same dimensions. That's why the volume is 1000 for all the boxes. So you can see now we have used a constructor. So both box objects here were initialized by the box constructor, and they were given the same dimensions, as you can see. That's why the volume is the same. They were initialized and they were given the same dimension. Now, when you don't define an explicit constructor, Java creates what we call a default constructor for the class, and then it initializes all the instance variables of that particular default constructor to 0. So this default constructor is sufficient when you're creating some simple classes, but it is not going to be sufficient when you're creating more complicated classes. Thus you as a programmer needs to actually define your own constructor, and when you define your own constructor as a programmer, that makes the default constructor one unused. In other words, it will not be used. So we have used a constructor that we are assigning values right in the constructor. Now we will need to use a constructor that handles parameters. As you can see here in our constructor, we have a parenthesis where we can put parameter list. Okay, the constructor in the meantime have all the boxes having the same dimensions, and this is not useful. As you can see, when we print here the results, we get 1000, 1000, because whichever box that we are going to declare, we are going to create, it is going to have the same dimensions. So we want a constructor that is not going to have it will allow us to get the volume of any box. So we need a way to construct box objects of various dimensions, and to solve this, then we need to add parameters to the constructors so that we can make this constructor more useful. So we can come to our constructor here and add our parameters here, and the first parameter will say double w comma double h for height comma double double we have width, height, length, so double L for length. Then we're going to initialize width to W here, width to W. You're going to initialize height to H, and length to L, length to L. That's very important. Then from there we can compute and we return the volume. So whatever we are doing in this method that computes and returns the volume won't change. It's going to be the same. We are returning width times height times length times height. So I want us to also move to our main class. Now when we move into our main class, we want to be able to get the volume of any type of a box. So whenever we actually create this, we will need to give it values. For example, my box 1 has the values of 10, 20, 15. Remember I said what we give into methods are known as parameters, but what we supply when we are calling methods or when we are creating objects are arguments. So we are giving 10, 20 and 15 as arguments for my box 1. For my box 2, we are going to give 6, 3 or rather 5 or 9 and 9 as arguments. Okay, we're going to give that as arguments. Now if we want to get the volume of any other box, we just need to change the measurements in here. We don't need to go and affect the constructor. We just change the arguments that we are supplying. So if we run this, we check, we are getting 3035. As you can see, are the results of this computation, because we are using parameters. In this case we are using parameters. Okay, I hope that's clear. You see we have used parameters here in our constructor. Yeah, in our constructor here. Now at times a method will need to refer to the object that invoked the method. So to accomplish this, Java is defining to us a keyword, and the keyword is this THIS, that can be used inside any method to actually refer to the current object. So the word is always a reference to the object on which the method is actually invoked. So we can come here and change this. I mean, just improve this using this keyword. This dot width is equal to, then we can also say here this dot height is equal to H. You can also come here and say this dot length is equal to 1. Now the use of this in this particular example is redundant, but it's perfectly correct. It is actually useful in many other contexts that we will see. So inside the constructor, this keyword is always going to refer to the invoking object. Is always going to refer to the invoking object. Now Java cannot allow declarations of two local variables with the same name in the same scope. We talked about scope. So you cannot declare, like let me just show you in this class here. We cannot come here and declare another variable and we call it length, because we already have a variable known as length. Now when we declare that, when you check this error, you see duplicate field box dot length. So you in Java you cannot declare two local variables that are in the same scope using the same name. So it's very interesting rather that you can have local variables including formal parameters to methods have the same names, just like the class instance variables. So in methods it's actually possible. However, when a local variable has same name as an instance variable, the local variable hides the instance variable. This is a concept I call instance variable hiding. Now this explains why I did not use width, height and depth as the names of the box constructor parameters. When you'll come here, you see for this constructor I use double W, double H and double L. I did not use length, height and width. Why? Because if I use these variables in here, there will be data hiding. Okay, these local variables in here are going to hide these variables here. Okay, so it's important to understand. Now it's easier to use different names, but there's also another way around such a situation. Since we have the keyword this that actually lets us refer directly to the object, then we can use this keyword to actually resolve the namespace collisions, and that is why I have used it here. I'm explaining why I'm using this. I'm trying to prevent the namespace collisions, because if I use the same names in here, then there will be data hiding. Hope you got that right. So the use of this can sometimes be confusing, and some programmers are careful not to just use local variables and formal parameters that hide instance variables, but others actually believe that it is a good convention to use the same names so that you can gain clarity, and then use this to actually overcome the instance variable hiding. Another important concept that we need to understand as Java programmers is garbage collection. Remember, we talked about garbage collection as a feature of Java. Now, objects are dynamically allocated using the new operator. Now the question would be, how are these objects destroyed and have their memory released for a later reallocation? If you look at languages like C++, dynamically, when we have dynamically allocated objects in C++, those objects are manually released using the delete operator manually by the programmer. But Java automatically handles deallocation by a technique that is called garbage collection. Now, this is how garbage collection works. When no reference to an object is actually existing in that particular program, that object is assumed to be no longer needed, and the memory that is occupied by that particular object can be reclaimed. So garbage collection occurs during the execution of your program, and that is actually happening sporadically. So now, taking a scenario where an object is holding some non-Java resource. For example, you have a method that is actually holding a file or a character font that you don't want to or you want to make sure that these resources are not lost. These resources are freed from that object before the garbage collection comes and destroy that object. Java provides us with a mechanism known as the finalize method that handles this particular scenario. So the finalize method allows you to define some specific actions that will occur when an object is about to be reclaimed by the garbage collector. So when you add a finalizer to a class, you are simply or it simply involves defining the finalize method. Then the Java runtime is going to call the method whenever it is about to actually recycle an object of that particular class. When an object of that particular class needs to be recycled, that finalizer method will be called. So in the finalizer method, you will just specify a number of actions that must be performed before an object is actually recalled, or before an object is destroyed. So more of this later. I'm going to handle that later. In the meantime, what I wanted to introduce to you are constructors. So guys, we are going to stop there for now. I'll meet you in the next lesson. I'll be talking about overloading methods.